My name is Caleb Dunn, and today we're going to talk about clonal expansion and clonal anergy and the differences between the two. So, before we begin talking about clonal anergy, we'll do a brief overview of what clonal expansion is. This was first discovered in 1900 by Paul Ehrlich, and he proposed that the binding of the receptor of an antibody to an antigen is like how a key fits into a lock. And his theory was pretty widely accepted, and there was one refinement being that instead of one cell making multiple copies of different receptors like he had originally thought, many cells made different copies of the same receptor that is specific to a particular antigen. So to further explain clonal expansion, let's say we have two different cells, the first being B cells and the second being T cells. And B cells originally begin in the bone marrow, while T cells originate in the thymus. And each of these cells are going to have a particular antibody, and they'll be able to bind to a specific receptor. So once these are made, they are going to travel to the lymph node. So once they travel to the lymph node, they are actually going to lie in wait. And what they're going to do is they're going to wait for a particular antigen to be presented to them. And this can happen in one of two ways. And the first way is the antigen can actually just end up in the lymph node on its own, or it can be engulfed by an antigen presenting cell, and it will bring it inside of this lymph node, and it will actually present the antigen itself to these antibodies. So we have two antibodies that will line up with these particular antigens, and it'll be these two. There's going to be one B cell, one T cell, and these cells are now going to divide. They're now going to make multiple copies of themselves. But now, rather than make different cells with different receptors like it was up here, now you're going to have each cell having the same receptor. So now you have many more cells rather than just one B cell, one T cell. Now you have multiple cells that can attack and defend against this particular antigen. But what happens if the immune system fails to respond to a particular antigen? Now, in this case, it would be considered clonal anergy. So clonal anergy is when lymphocytes, unlike in clonal expansion where the lymphocytes respond to the antigen that's presented to them, they can't mount a defense against a specific antigen. So in the case of this, we'll go back just a little bit in clonal expansion. Let's say that the antigen presenting cell here and the antigen itself end up in the lymph node, but the B cell and the T cell, they don't respond to them. So this does not happen because the immune system just isn't going to respond to this particular antigen, and now it can't mount a defense. So in other words, they can't amplify an immune response, and therefore they become inactivated. So this phenomenon was first discovered in B lymphocytes by a biologist by the name of Gustav Nassai, and this was termed clonal anergy. So the clones of B lymphocytes in this case can still be found alive in circulation, but they're not very effective at mounting immune responses at all. And there are different viruses that will exploit the immune system of tolerance induction, anergy being one of three processes that induce tolerance, and the other two being clonal deletion and immunoregulation. But these viruses, like HIV, they can exploit the immune system, and they can use this to actually evade the immune system. So a small number of the body's army of lymphocytes that are actually being made up here, they're able to react with proteins that are normally present in a healthy body. And the clonal expansion of these cells can lead to autoimmune diseases if they react to these proteins. And this is going to lead to the body actually attacking itself. Now, in order to prevent this process, lymphocytes can possess an intrinsic quality control mechanism. So what this means is it will shut down the lymphocytes' ability to expand if the trigger for the expansion turns out to be the body's own protein. So in this case, T cell energy can arise when the T cell doesn't receive stimulation in the presence of a specific antigen recognition, meaning that this T cell will not be able to expand. They're not going to replicate if it turns out to be the body's own protein, because then the body will just end up attacking itself. Now, B cell energy is a little bit different. It can be induced by exposure to a soluble circulating antigen, and it's marked by downregulation of surface IgM expression and partial blockades of intracellular signaling pathways. Now, that's not to say that clonal energy is all bad. It can actually be taken advantage of with the immune response. This can be used to graft transplanted organs and tissues. This can be minimized without weakening the whole immune system. And it can also be used to induce activated lymphocytes to become unresponsive with different diseases like diabetes, multiple sclerosis, rheumatoid arthritis. These lymphocytes won't be responsive to these diseases. And in response to a tumor growth, preventing anergy will actually help in anti-tumor responses, and it can also be used for immunotherapeutic treatment of allergies. And that is the difference between clonal expansion and clonal anergy